This is a homework problem from section 3.6. I think it's either number 3 or number 4. It says a building consists of 2 floors. The first floor is attached rigidly to the ground, and the second floor is of mass 1,000 slugs, FPS units, and weighs 16 tons, which is 32,000 pounds. So mass is given to us as 1,000 slugs, and the weight is given to us 16 tons. And it has converted it by multiplying tons by 2,000 pounds, and it has converted this to 32,000 pounds. So now it says the elastic frame of the building behaves as a spring that resists horizontal displacements of the second floor. So our K is the elastic frame of the building. And it requires a horizontal force of 6 tons. 6 tons, that is the force. To displace the second floor a distance of 2 feet. So X is equal to 2 feet. So then it's just saying that it requires 6 tons to displace the second floor 2 feet due to the elasticity of the building's frame. So building's frame is our K, and we could find a K from what we have. But then it says, assume that in an earthquake, the ground oscillates horizontally with amplitude of A0 or A0, and circular frequency omega, resulting in an external force of F of t is equal to MA0 omega squared sine of omega t on the second floor. So that's the external force. What is the natural frequency? So part A, find the natural frequency. For these word problems or for these motion problems, we always have a natural frequency, which is called omega naught. And then we have the circular frequency, which is called omega. And then it says if the ground undergoes one oscillation every 3.5 seconds, the period is given to us. So if the ground undergoes one oscillation every 3.5 seconds with amplitude, that is your A0, equals to 9 inches. What is the amplitudes of the resulting force? Find the that's what you want to find. So we want to find the amplitude of the resulting force oscillating of the second floor. So we want to find the amplitude, that is the capital A, and we want to find the natural frequency. But to find the natural frequency omega naught, we have this formula, K over M. M is given to us, we have to find K. So how do we find K? This is where the information for K is. We know that 6 tons, that is the force. but we need to convert it into pounds. So we know that there are 2,000 pounds in 1 ton. And we cancel, we get 12,000 pounds. That is the force. And X is equal to 2 feet. So we know the formula is F is equal to KX. So then F over X is equal to K. And F is 12,000 divided by 2 feet. That gives us 6,000, which is equal to K. So then omega naught, which is part A, is equal to K over M, and K is 6,000 over mass 1,000 is a square root of 6. To answer part B, we know that, let's write down our equation for this motion. We know that there is no damping, so C is equal to 0. We have the formula that says mx double prime plus cx prime plus kx is equal to some force, external force. But C is equal to 0, there's no damping, so this is what we have. And F is given to us as MA naught. This F is MA naught, so let me just write it. We also could find omega because the problem has given us the period for this problem. So if we have the period, then omega is equal to 2 pi divided by t, which is the period. So 2 pi divided by 3.5. So let's calculate this. It is equal to 1.7952. So I went 4 decimal points. That's about, okay? So that is the omega that we need. Let's go back to the formula. M is 1,000, X double prime, K is 6,000, X, M is 1,000, A naught is given to us as 9 inch. We have to convert. So watch out, this conversion is always very tricky. I sometimes forget to do the conversion, but everything should be in feet. So this has to be converted from inch to feet. Omega squared. I'm not going to put the omega value yet because we have to do a lot of calculation. We do the omega later. So anyways, I'm going to divide both sides by that 1,000 to simplify this a little bit. And I'm going to reduce that to 3/4. So I get x double prime plus 6x is equal to 3/4 omega squared sine of omega t. So we want to find a particular solution because that is what we are interested in. For a particular solution, we are going to let's say, x of particular equal to c cosine omega t plus a sine omega t. So these are the unknown coefficients, and we take the angles to be the same as that. And then we find x prime, which is minus c omega sine omega t plus a omega cosine omega t. So derivative of cosine is negative sine times derivative of the angle, which is omega. Derivative of sine of omega t is cosine omega t times derivative of the angle omega. Then we find the second derivative, which is going to be minus c omega squared. Derivative of sine is just cosine omega t, and the reason this becomes omega squared because we have to find the angle's derivative. Omega t's derivative is omega, so we get squared. Minus, because again, derivative of cosine is sine, negative sine, and derivative of omega t is omega, so that's why we get another omega here, omega squared sine of omega t. So let's substitute them. I'm going to put this for x double prime, so we get minus c omega squared cosine omega t minus a omega squared sine omega t plus 6 times that, which is 6 c cosine omega t plus 6a sine omega t is equal to 3/4 omega squared sine of omega t. So now we are going to set this and this together. So we have minus c omega squared cosine omega t plus 6c cosine omega t is equal to 0. Because we don't have any cosine on this side, so we set it equal to 0. If I factor, I'm going to divide by cosine omega t. That's how we solve for the coefficient. We get rid of the cosine omegas, and then this implies that if I factor the c out, so that implies c is equal to 0. So c is equal to 0, then we are going to set the other ones, like these guys, equal to sine. So now our other equation is minus a omega squared sine omega t plus 6a sine omega t is equal to 3/4 omega squared sine omega t. And again, we are going to get rid of all the signs and leave the coefficients. We get minus a omega squared plus 6a is equal to 3/4 omega squared. We are solving for a, that is the amplitude of the problem. So to find the amplitude of the problem a, I'm going to factor it. I get negative omega squared plus 6 is equal to 3/4 omega squared. I divide both sides by the coefficient of a. So I get a is equal to 3 omega squared over 4. And then I'm going to swap these 6 minus omega squared. Now I'm going to substitute omega. And omega is 1.7952 squared divided by 4, 6 minus 1.7952 squared, squared inside the parentheses. So let's see what we get. We are going to find 1.7952 to the power 2. And we have to multiply that by 3. We have to divide that by 4 times 6 minus 1.7952 to the power 2. And I get A is 0.87, or roughly that's what I get. and this is in feet. And then at last, I think it wants the answer in inches. So then I have to multiply that by 12. So I get A is about 10.44 inches. There's also a formula that I have driven that you could have found the answer, but then you just had to accept that the X particular is only sine of omega. But I went through the whole thing to show you that this C becomes 0, and if C is equal to 0, I don't have to find C, which is equal to A squared plus B squared. That is the amplitude. But since B is equal to, or since, you know, this coefficient is equal to 0, in this case, C is equal to 0, then this is not going to be there, and that is our only amplitude here. So I didn't have to use this function. But there's another formula that I have shown you in one of the videos that I have posted in section 3.6 that says this is equal to F naught over square root of K minus M omega squared squared. I don't remember, is it plus or minus C omega squared? And since we don't have any damping force here, this is a plus. Since we don't have any damping force, C coefficient C is equal to 0, so this is equal to 0. And this 2 and the radical cancel each other. You get F naught over K minus M omega squared. And in our case, our F naught was just, what we had was M, A. We don't put the sign because our signs are going to be canceled, omega squared. And that is our F naught. And this formula also works. But anyways, that's what we get.